website. It is a one website. What we are doing? We are interacting with that website. That means we are the clients. Okay, customers. So we are ordering some product. So whatever the product we are ordering here, so that will go to the server. The server will placed in some place, whether it is in India or out of India. I think it is out of India, so Flipkart is not a India-based one. I think so. I don't have such much idea about it. Okay. Flipkart. So whenever we are requesting one thing from here in the Flipkart from our side, in our place, from our home or from our laptop, so it is going to the server. The server will be placed out of the India or out of the country or out of the state, whatever it is. Wherever it is, it will go for the server. When it will reach the server, then only it will be confirmed. The confirmation message will come to you. Okay. So the relationship between client, this is a client, and this is a server. Flipkart, both are the Flipkart. This is also Flipkart. But the website which you opened in your system is we are the client based. Okay, server class in some way, and a dependency relationship is established. So both two are dependency. Why it is dependent? So the server has to respond when the client or give you some request. So if you click on the buy option, so then it will go for the server system. Then server system, if there is any availability of that product, so it will give the confirmation to you. So for the payment. Okay. So dependencies are defined by a stereotype. So dependency is a type of stereotype. We call it as a stereotype. So what is a stereotype? Stereotype is an extensibility mechanism. That means whatever things we have, we can extend those. So within UML, only within the UML part. So that allows you to define a special modeling element whose semantics are custom defined. Okay. So in UML, stereotypes are represented in double angle braces like this. So these are the stereotypes. We call this indication is called as a stereotype. That means with the two angular bases. So within that what you define, that is a stereotype. We call as a stereotype. So we will see that is an example, no problem. Okay, and next, an important part of analysis modeling is categorization. So up to now what we are seeing the modeling. For what? Requirements modeling. Okay. So that means they are coming under the requirement analysis part. So that is various elements of the analysis model, example use cases, we are using the use cases, analysis of the classes. So up to now we have seen the analysis of classes are categorized in a manner that packages them as grouping. So whatever the classes we are representing, we can group them. Okay, so that is called as a packages. Grouping of some classes is called as a packages. Called an analysis package. We can also call as analysis package that is given a representative name. Okay. So whatever the classes you are representing, whatever the use cases you are representing, those are combined, we can call as a package. And next point is, see here. So this is a dependency. So there is no arrow mark over here, just it is a dotted lines. So with a stereotype. So within this stereotype, display window to camera. So axis. Okay, so this is an example for the dependencies. And next coming to analysis of packages. So up to now we have seen the CRC, up to now we have seen the what is the association and what is the dependency. So now we are going, the next part is analysis packages. So what is the analysis packages? So an important part of analysis modeling is the categorization. We have seen that, okay, use cases, analysis, classes are categorized in packages. So this is the analysis packages. And next coming to, so this is the one package. So what is a package? Package is nothing but it is a group of the classes. Okay, so environment, this is the one class. Rules of the game, this is the one class. Characters, these are the one class. So here you have seen some plus symbols. Okay, what are those plus symbols? If you click on this plus symbol, it will be elaborated. So it will give under the supporting rule, what are the attributes and what are the operations. So because if you represent all these things for these things, it will give some diagram will be elaborated. That's the reason they have given the some plus symbol. Or else, if you have the software in your system, NetBeans or MyEclipse, if you have these two softwares for the execution of the C or C++ or Java programs, so if you click on the open new project, then it will give some like this. It will give the like this. Okay. So that means this MyEclipse is a one package, NetBeans is a package. Okay, like that you can see. So this is the package diagram, and this is the why we have to analyze the packages. Because representing the each class, that means for example, for Java, in order to execute the Java, you have some API, application programming interface. So what is the application programming interface? It is nothing but some group of packages. So what those packages have is the number of classes. For example, maths, we can say mathematics. Maths have some symbols, plus arithmetic, logical, we can say at the symbol, or some greater than symbol, less than symbol, like the different operations, logarithms, the exponentials. So those are the things, the different mathematical operations are there. So all those mathematical operations are called as a one package. Okay. So whatever the operations are there, they are represented in the classes. So those classes are called as combinedly called as a package. Math package. Or else, if you want to clearly know, for example, you people write the ash include in C language, ash include braces stdio.h. Why we are using this stdio.h in the ash include? So this is a one package. stdio.h is a one package. So this will have some input-output operations. In order to execute a printf, scanf operations, we have to write stdio.h. This is a one package. So that package contains some input-output operation classes. Okay, that is a package. And next, coming to the requirements modeling strategies. So up to now we have seen what are the requirement analysis. So what are the requirement models? So on class based how to model. Okay, so now we are going for the requirements modeling strategies. So what are the different strategies, different ways, different methods? Okay, so one way of requirements modeling called structured analysis. So one way of requirements is called as a structured analysis. So data objects are modeled in a way so that defines their attributes and relationships. We have known this because class is represented to define the attributes and operations and relationships we have seen previously. Okay, so process that manipulate data objects are modeled in a manner that shows how they transform data as data objects flow through the system. So in order to create a website, for example, I'm saying the website is one example. So this is the website. So this is some software I have to create. So in order to create this website, so the page, how many pages it is, should we have? 5 pages. So in order to create these 5 pages, I have to write the classes. class, home page, class, some next page maybe my profile page. Of course, we are seeing only the things on the website, but what are in the back end? So if you press the Control U, you are able to see the what is the source code of that website. Okay, if you press the Control U, you can able to see the source code of your websites. So how they have to write. So in HTML, how they are implementing all these things. In HTML, how the frames they are dividing the page into frames. You can able to see. So in order to write those programs, okay, what is the strategies for that? So how do we have to, what are the requirements given by the user, how we can to make some strategies on the different models. Okay, next coming to the second approach to analysis model called object-oriented analysis. So first one is the structured analysis, second one is the object-oriented. Okay, so this object-oriented focus on the definition of the classes and the manner in which they collaborate with one another to affect the customer requirements. So in the structure, what we have seen, in structure it will process about the attributes and relationships. So how the data will be transferred from one object to another object will be seen in the structured analysis. Whereas in object-oriented, it will focus on the definition of the classes. What is the class definition? That means what is the class name and the manner in which they collaborate with one another. So different classes are in object-oriented program, different classes we can represent. So in C language, only one class you have to write. Okay, but in Java program you can write the number of classes. So that's why this is an object-oriented program. Different class A, class B, class C. Like the different classes we can represent within one class. So how they are collaborate, in which they are collaborate, in which they have to transfer. So how they are satisfy the requirement, customer requirements. That is the object-oriented analysis. And next one is flow-oriented modeling. Okay. So those are the two types of requirements modeling strategies. One is the structure-oriented and next one is the object-oriented. And next coming to the flow-oriented modeling. So what is the flow-oriented modeling? So flow-oriented modeling is pursued as an outdated technique by some software engineers. So it is outdated because it continues to be one of the most widely used requirement analysis notations in today. Why it is a old one is because in this the flow is a data flow diagram. So data flow diagram from the old days onwards it is represented. Okay, what is the data flow diagram is? It is nothing but the how the data is flowing from one object to the other object. So it is the representation of the flow-oriented modeling. So I think you will learn about the flow chart. The same thing is a data flow diagram. So from one data to another data, how the flow is happen. So that is a data flow diagram. So the purpose of the data flow diagram is to provide a semantic bridge between the users and system developers. So who are the users? And also who are the developers in between two. So it acts as some bridge between these two. So that is a data flow diagram. That means whatever the requirements given by the user, according to that, the developer will draw some data flow diagram. So after this in the website, for example, website design. In website designing, after creating the home page when they click on the My Profile, it has to go for the My Profile. So that means data is transferred from one page to navigating. Okay, so they can represent that in a data flow diagram. And next. So the data flow diagram takes an input process output view of a system. Takes an input process and output of view of a system. Why is I think you people know about the first start. So after start. So login. After login, you will get a home page. So when it will get home page, if the password is correct, if the password is wrong, then what to do? Again, it has to go for the login loop. Here we have to provide some loop. That means we are seeing the how the data is flowing. If you do like this, so what next step will go for? If you do like this, what the next step will go for? So flow chart, okay? So I think you people know about this. So that is data objects flow into the software and transferred by processing elements and resulting the data objects flow out of the software. So in the software, how the data objects will connect, how the data objects can be moved from one page from one to another. So that can be represented in a diagrammatic way is the data flow diagram. Data objects are represented by labeled by arrows. So how they are represented, so I have seen it shown like arrow mark. So they are represented by arrows. And transformations are represented by circles and also called as a bubbles. They are also called as a bubbles. Okay. And next coming to the DFD is represented in a hierarchical fashion. So what is a DFD? DFD is represented in some hierarchical fashion. So that is the first data flow model called as a level 0. Level 0 DFD. Or context diagram. So whatever the diagram we have, so in that diagram we can call as a level 0. The first diagram of a software, the first diagram of first level of a diagram is called as a level 0 DFD, or also we can call as a context diagram. I will show the picture format. Okay, no problem. So represent the system as a whole. For example, website creation. Website creation. So what is a website creation? In website creation, so what we have, the user said, I want a 6 pages website. Okay. So first one is the home page. Second one is the login page. Then sign up page. And next we're coming to some product page. So after the product, you can go for the payment page. So confirmation page. Whatever the pages you are getting in the website, those are the different pages. Okay. So these are I have given 6. These are 6 pages. The user said I want these 6 pages of the website. Okay. So first, when he reached the developer, so he has to say that I have wanted 6 pages of website. Then the developer, what he will do is he will take some data flow diagram. So data flow diagram of level 0. So in that level 0, the whole thing will be represented. Okay, like first go for some start button, and then go for, so here they use some circles. Okay, home. First we'll go for the home page. After the home page, you can go for the login or sign up. So if it is a login page, what he has to give? He has to give the login credentials. If it is a sign up page, so he has to register. So if the login page, after giving the login credentials, if it is yes, what will happen? If it is no, what will happen? No means the login credentials are wrong. If the login credentials are yes, then he has to go for the next page. So like this, we have to represent the whole system, whole software in one diagram. So the diagram is called as a level 0 or as context diagram. Okay. So subsequent data flow diagrams refine the context diagram providing increased detail with each subsequent levels. So whatever the levels they are using. So in level 0 we represent the whole system. Okay. So in order to in home page, what are the things we can provide? In login page, what are the things we have to provide? In product page, what are the different products? That means in product page, we have some more pages. Okay, for men's, for women's, for kitchen, for accessories or for mobiles. Like that we can divide so many of the pages in the product page. Okay, so like that there is some subsequent diagrams. So those subsequent diagrams can be refined from the context diagram. Whatever the context diagram, that means level 0 diagram we have drawn. From that we have to take from each unit we can develop some more diagrams. Okay, so that is providing increasing detail with each subsequent level for each level. So what are the things we can develop for some other level? What are the things we have to develop? Okay, so that is a thing. And next coming to the, so this is the context level DFD diagram for the safe home security function. So that means level 0. So this is the level 0. Level 0 DFD diagram for safe home security information. Okay. So I given the example for the website. This is for the security for safe home. So this is the software. Okay. So what I said in level 0 we will provide the whole system. How the system will be appear after the development of the software. Okay. So in this, so first control panel. So whatever the controls user will do. So and it has some sensors, sensor status. So who came to this, who came under the software, home. So what is the safe home software? So in order to avoid some theft, in order to avoid some more improper conditions that occur in our houses. So in order to view those. So this safe home software is existed. Okay. So this safe home, the context diagram is like this. So what is the control panel? So this control panel what to display? So whenever a theft, that means a thief, whenever the thief came, so this safe home has to sense and it has to display in the control panel. So or else it has to give some alarm. So it has some alarm. Okay, and also it gives some information to the telephone department or through telephone, through police or through the owner, whoever it is. Okay, so like this, that means the safe home software will have these other things. So this is the overall diagram of the safe home security software. Okay, so this is the context level. And next coming to the data flow diagrams. How do we create the data flow diagrams? So the data flow diagrams enables you to develop models of the information domain and functional domain. So what is the information in that? See here in the data flow diagram. So what are the things we have to provide? What is the information is passed from one to another type? Okay, like that. So in data flow diagram, we will represent both the information domain and also functional domain. So their alarm type is there, telephone type is there, and it also is there control panel. That is a So the data flow diagram enables you to develop models of the information domain and functional. So that means information. So what type of software? The software it contains. Okay, and also it gives the what is the functional in that. So why we are using the alarm type? Why we are using the information? I mean, there is some telephone. So we can use both or we can use only one. So there is what are the different ways we can use, like that it will provide. Okay. So as a DFD is defined into greater levels of detail. So if you go for the in detail format, some in detail format, okay, so you perform an implicit function decomposition of the system. So how the system can be defined, divided into some subtypes. So in the safe home, so the level 2, we can see later. Okay. So at the same time, the DFD refinement results in a corresponding refinement of the data. So what is the refinement is nothing but again we are going into the deeper level. So this is the overall diagram. So what is the part of the control panel in the safe home software? So that is the one part. What is the sensors? How sensor will sense the human? How it will act in this safe home security software? So that is the one level. Okay. How control panel has to display? Whether it display the photo of the person, or whether it displays the somebody came like that hint he has given. What is the thing it will give? So that is the one information. So next one is the alarm. So what type of alarm? Well, alarm to only to the home guard, or alarm to the police station, or alarm to the some more people. What type of that? So that is the one thing. And next one is the telephone line. So telephone line is nothing but whom it has to give the send the information, whether to the police or whether to the home guard or whether to the some owner, like that. Okay, like that we can divide the some subparts. So this is the overall diagram of the DFT. So at the same time, the DFT refined results in a corresponding refinement of data as it moves through the process that embody the application. Okay, when it goes implementing the product, when you go implementing the software, so it will goes. The refinement will be done. So a few simple guidelines can aid immediately during the derivation of a data flow diagram. So some guidelines has given for the in order to draw the how to draw the data flow diagram, how to take the refinement of the data flow diagram. So the first one is the level 0. This is a 0, not 1. The level 0 data flow diagram should depict the software system as a single bubble. So whatever the software diagram you are doing, it should be in a single bubble. That means it should be in a single place. The second one, primary input and output should be carefully noted. So what is the primary input here we are giving? What is the output we are getting? So we have to note. So next, the third point is refinement should begin by isolating candidate process, data objects and data stores to be represented at the next level. So when sensor is sensing something, so what type of the output it will come? So where it has to be go? So the sensor, what is it sensing? It has to be stored in the control panel, or it has to store in the telephone line, or it has to store in the for alarm. So what it has to do? So that is this process. It has to be stored and to be represented in the next level. So what is the next level for that? So after sensing that sensor, so the information should send to which? Where? Okay. And next, coming to all arrows and bubbles should be labeled with the meaningful names. So whatever the bubbles is nothing but the circle what it is giving. So what is the representation? What are the arrows we have to present over there? They have to be labeled with the meaningful names. Whatever the things you are giving. For example, see in this data flow diagram. So here, so it is giving this is the arrow, and here it is giving the some label. Label is nothing but the some information. So the control panel, what it gives? User commands and data. It gives to the software, safe home software. Or else control panel will give this safe home will give the display information. What information should be displayed to on the control panel? This is the display information. So sensors, whatever the sensors is the sense, the status has to be given to the software. So that is that they have given us some labels for the arrows. Okay. And next, fifth point is information flow continuity must be maintained from level to level. So whatever the information you are drawing, so whatever the data flow diagrams, we have seen the data flow diagrams level 0. So that means overall diagram. So then go for the level 1. In level 1, so what are the things you consider in the level 1 data flow diagram? So after that level 2. So whatever the levels you are taking, there is a continuity in between those two. So without continuity, you can't draw the data flow diagrams. And next, the sixth point is one bubble at a time should be refined. There is a natural tendency to overcomplicate the data flow diagram. Okay, so we have the one bubble. One bubble is nothing but a software. So whatever the software is, that is a one bubble. Should be refined. Refined means it has to be get. Okay, there is a natural tendency to overcomplicate the data flow diagram. So if you take the more bubbles, that means more and more implementation of the softwares within the single data flow diagram, then it will make some complication to develop the diagram. And next, see, this is a data flow diagram of level 1. So previously we have seen the level 0 data flow diagram. So this is the level 1 data flow diagram. So in this level 1 diagram, see what is here. So there is no software here. So it is giving the, so how the control panel will give. So control panel, user commands and data to when user interact. So and also it gives the information to the configure system. So that configure system, it gives the data to the some configuration information. So that information go for the monitor sensors. So what are the status here? It is going for the monitor status. So whatever the process it is going, so here when user interact, it will ask the password. So whatever the password he has given, it will be processed. After the processing, it will go for the display the messages on status. So what is the status? What is the messages he has? Or else, if you want to stop, if you want to activate or deactivate the system, so here. So if you are activate or deactivate mission, so it will give the some display messages. So whatever the display messages, it will go for the, in order to display, it has to go for the control panel to display. So like this, the whole safe home system, security system is level 1 is like this. In level 2, it will be some more detailed. Okay, and next. So the summary of this session is, so we have seen what is the CRC, and next we have seen what are the responsibilities. We have seen about the association and dependency. And next we have seen the flow oriented model, flow modeling. So after flow modeling, we have seen the DFT.